All right, good morning, folks. This is Mike coming back at you with another video on Introduction to Algebra. In the previous video, we talked about factoring polynomials, specifically through factoring out the greatest common factor or pulling out the greatest common factor. In this video, we're going to focus on factoring a particular type of polynomial because we do it so often that it really is worthy of having its own video. We're going to talk about factoring trinomials. A trinomial is a polynomial with three terms. And when we factor a trinomial, we get two binomials. So you multiply two binomials typically, and you get a trinomial. So just one super quick sample just to show you what the heck I'm talking about here. X plus 2 times x plus 5. If you multiply these polynomials, as we learned how to do in chapter 4, x squared plus 5x plus 2x plus 10, the 5x plus 2x combine to give you the 7x, and you have the x squared plus 7x plus 10. So now we're going to see how we sort of go in the opposite way. We're going to see how we start with something like this and get down to something like that. And this is the nicest sort of case that we can see because the number in front of x squared, or the coefficient of x squared, is 1. And that is the nicest possible case that we can have. So to factor something that looks like this, to factor something that looks like x squared plus or minus some number b times x plus or minus some number c, we want to write this as x plus or minus some number times x plus or minus some other number. And our goal is to figure out what these things, what m and n, have to be. That's what we have to figure out. They could be positive numbers. They could be numbers that are negative. We'll see. So I'm going to sort of work with this thing here, and we'll see why what we have to look for is indeed what we have to look for. So if I multiply x plus m and x plus n, if I multiply these two things, what am I going to get? Well, I'm going to get x squared plus nx plus mx times mn. And I want to look at sort of combining a couple of these terms. These two terms here, the nx and the mx, have a common factor of x in them. So I can pull that x out of just those two terms and write it as n plus m, that sum times x. And I want to compare this to the x squared plus b times x plus c. And when you compare these things, these two things have to be the same. These two things have to be equal. So if I set these two things equal to each other and I compare these things, we see some nice sort of rules that we have to follow to find out what m and n are. I compare these two terms here, b times x versus n plus m times x. That's telling me that b and n plus m have to be the same. They have to equal each other. If I look at this last term here, plus c versus plus m times n, I know that these two things have to be equal to each other. So this is why we say what we have to look for and what we have to think of is we have to think of numbers or values for m and n that will add to whatever my b value is, whatever the number is in front of the x, and those two numbers, m and n, also have to multiply to my c value, whatever is at the end here. So we're going to do this with some of these samples here. So we'll go step by step sort of with this first one here, x squared plus 3x plus 2. The key thing here, the first big thing, is correctly identifying what are your b values, or what is your b value and what is your c value. The b value is the number as well as the sign in front of your x. So plus 3, that's my b value there. The c value is the number and the sign that is at the end. So in this case, plus 2. So I have my b and my c value. I need to come up with two numbers that will add to my b value, that will add to positive 3, and those numbers also have to multiply to my c value. They have to add, or they have to multiply to positive 2. So numbers that will multiply to positive 2, we are looking at factors of 2. So what numbers can we multiply to get 2? Well, we have positive 1 and positive 2. Okay, if we add those numbers, does that sum give us positive 3? Well, yes, it does. So we have found the numbers that we want. We want positive 1 and positive 2. So we take our m and our n value. It doesn't matter which one is which. We could choose this one to be m and that one to be n, or vice versa. But either way, we're going to take our m and our n values, and we're going to substitute them in. So we're going to have x plus m plus 1 and x plus n, or plus 2. We'll do this with a couple more of these things here. X squared minus 7x minus 18. Okay, I want to identify my b value and my c value. The b value, again, is the number as well as the sign that is in front of my x. So that's the negative 7. The c value is the number and sign that is at the end, the minus 18. So I need to come up with two numbers that will multiply to negative 18 and will add to negative 7. Now, if numbers are going to multiply to a negative number, then that means one of our numbers has to be negative and the other one has to be positive. So let's think of some factors that will multiply to negative 18, and we'll see if those add to 7 or add to negative 7, and whichever one makes both of these true, that's the one that we want. So let's think. Okay, so I have negative 1 and positive 18. Those will multiply to negative 18. Do those add up to negative 7, though? A quick mental check, or if you plug it into your calculator, you'll find no, they don't. So those don't quite work. I have positive 1 and negative 18. Those multiply out to negative 18, but do they add up to negative 7? No, they don't. Okay, I have negative 2 and positive 9. Those multiply to negative 18. Do they add up to negative 7? No, they add up to positive 7, so we're close, but not quite there. What about negative 9 and positive 2? They multiply to negative 18, and this pair of numbers does add up to -7. So -9 and +2. Those are the numbers that I want. Those are my m and my n values. So this trinomial right here is going to equal x plus my m value, so plus a -9 or -9, times x plus my n value, plus 2. And that's how we factor this trinomial. Okay, let's work with this one here. X squared minus 9x plus 20. Again, identify your b and your c values. The number and sign in front of the x is your b value. The number and sign at the end is your c value. So I need two numbers that will multiply to +20 and add to a -9. Now, if you have two numbers that add up to a negative number but multiply to a positive number like we have here, then both of those numbers have to be negative. All right? If two numbers add to a negative number and multiply to a positive number, then both of those numbers have to be negative. So now I am looking at factors of 20. Both the numbers have to be negative, and these numbers have to add up to a -9. Okay, how about -1 and -20? They multiply to +20, but they don't add up to -9. They add up to -21. Okay, how about -2 and -10? They multiply to 20, but they don't add up to -9. They add up to -12. How about -4 and -5? They multiply to +20, and in this case, they do add up to -9. So -4 and -5, these are the numbers that I want. So we take our trinomial and we say it's x and then my m value minus 4 times x and then my n value minus 5. So there's another sample of how we sort of use this thinking to help us factor a trinomial. Well, sometimes it's not possible. Sometimes you can't factor something in this particular way. This one right here is a good example of that. X squared plus 5x plus 1. So if we identify our b and our c values, the b value is +5, the c value is +1. I need numbers that will multiply to +1 and will add to 5. Well, there's only two ways that we can choose numbers to multiply out to +1. There's either 1 and 1, or there's -1 and -1. But the problem is, in either of these cases, if you add up those numbers, you don't get 5. 1 and 1 is 2, -1 plus -1 is -2. So we cannot factor this trinomial using this method. It's not possible. It's not going to work. Our only two possible cases do not work. So sometimes this method doesn't work. We'll talk later on in this chapter about another formula we can use to sort of help us factor these types of trinomials here. So we're going to stop it here for now. In the next video, we will continue on with this section. We'll talk about one other little thing you may have to do first before you try to factor a trinomial. That trick is going to be used when you have higher powers of x being used, not just x squareds, x's, and constants. So if you have any questions or comments, please be sure to reach out to me, guys. Send me emails, stop into my office hours, stop into my tutoring hours, talk to me after class, leave voicemails, messages on biplanes flying through the sky, SOS bonfires, bat signals, whatever. Until the next video, take it easy, guys.